Good morning, class. Whatever time it is for you. I'm broadcasting today from my boyfriend's house. So you get a little bit of change here. Headed home today, got to stay home from now on. Let's see. I am going to talk about Objective 2, Chapter 9, Objective 2, and for that, I'm going to need my Chapter 9 lectures. So let me go ahead and share the screen here with that. Okay. So I'm going to get to a slideshow here. I should probably do this before we even start, right? Okay. So today I'm going to talk about how experiments demonstrate causality, and that is objective number 2. So let's take a look at that. Well, there are 3 things that give us a sense of causality. Causality is, does one thing cause the other thing? So we've talked about correlation, where 2 things go together, but it doesn't necessarily mean that one causes the other. So, you know, if ice cream sales and warm weather go up together, that may mean that one causes the other, but it doesn't necessarily mean that one causes the other. Maybe that people with warm weather, they're more likely to have time in their hands, or kids to be out of school or something like that. And it's not the warm weather that's causing the ice cream sales, but they do go together. Okay, so at any rate, there are 3 things that give us causality in an experimental design. And the third one is perhaps arguably the most important. The first one is association. Are the 2 things associated together? Do they go together? Does changing one variable change the other variable? So for example, let's say vitamin C and illness, right? So if you take more vitamin C, are you less likely to get ill? Do they go together? Are they kind of going together in time? Are they associated? So same use of the word association as we've always had. Okay, temporal priority. Temporal priority does one come before the other? So for example, if you take vitamin C first and then your illness goes down, one's coming before the other, right? You don't want the illness to go down and then the vitamin C comes after that, obviously. For one to cause the other, it has to come first, right? And then finally, and this is the one that we're going to spend a little bit more time on, is elimination of alternative explanations. So getting rid of any alternative explanations. And in this case, what you want is the only difference between groups to be the independent variable. And remember, the independent variable from the last lecture is the cause. And we do this using control. So let's say we wanted to see if vitamin C prevented illness. We would want to make sure there's one group that has vitamin C that gets vitamin C and one group that doesn't get vitamin C, and then we're going to look at them and see what their illness is. Now, what we want to make sure is that those 2 groups are exactly equal, and for the most part we do that using random assignment. Every single person flip a coin, you get to the vitamin C group, you get to the other group. And that's how we do it. And then we make sure everything else is the same. So that's fairly easy to do if you've randomly assigned. Okay, so experimental control, what does that mean? To control, it's keeping everything exactly the same except for the independent variable. So what we wouldn't want is the people who are in the vitamin C group to also exercise more than the people in the no vitamin C group. We want to make sure exercise is exactly the same. We want to make sure diet is exactly the same. We want to make sure everything that they do is exactly the same. Because the only difference we want is for this group to have more vitamin C than this group. That's it. That's the only difference. And if we find out that one group is less likely to get sick and it's that vitamin C group, then we know it's because of vitamin C, because nothing else is different between them. So we call that internal validity, is the extent to which we are sure that it was the independent variable vitamin C that caused changes in illness. And we have a real problem when something else causes the change. And so when there's we call this a confounding variable. So let's say that vitamin C group, right, also went to the gym more than the no vitamin C group. Well, then we'd have to say, well, going to the gym is a confounding variable. Or let's say the vitamin C group were also taking vitamin D, and the vitamin D group, the non-vitamin C group or the control group wasn't taking anything. Then vitamin D would be a confounding variable. It would be something else that could have caused the changes in health. Okay, we're going to move on to objective 3, describing the post-test only and the pre-test post-test designs. And we'll describe why a pre-test might or may not be included. And then we're going to stop this video and make another one on the remaining objectives. Okay, so the post-test only design is exactly what it says it is, really. You just have an intervention, and after that you have a test. Now the test is the measure of the dependent variable. So the design that we're talking about is the same exact design that I've been using for the vitamin C group. Okay, so we've got a group of participants here. You can see that here. We have a group of participants. We randomly assign them, and this is what these R's mean. With every single participant, we flip a coin, and we say, if you heads, you're in the experimental group, tails, you're in the control group, and these are our 2 levels of the independent variable, whether or not they get vitamin C. So here they get vitamin C, here they get a placebo. Placebo would be like a sugar pill, looks like vitamin C or some other kind of pill that has nothing in it. And then we measure their health status after a week or so. We measure the amount of sniffling and coughing and stuff like that, right? So we call this a post-test only because we measure the dependent variable only once here, and it's after the manipulation of the independent variable. Okay, let's take a look at the pre-test, post-test design. As you can imagine, since the post-test had to do with measurement of the dependent variable, the pre-test, post-test will include another measure of that. So let's take a look at that. So it's the same thing on this end, and over here, the only thing that we've added is a pre-test measure. So in this case, with the vitamin C group, what we would do is, or with the vitamin C experiment, we'd take participants, we'd randomly assign them just as we did before, but now we measure their health status at the very beginning. And I want you to think about why we might do that. Why would we measure their health status at the very beginning before they've ever had vitamin C or the placebo? Well, we'll get to that in a second. Why would we do that? So now we give them the vitamin C and the placebo, and now we do the post-test. So here's the pre-test in this design, and here's the post-test in this design. Okay, so let's move on and find out why might we do. Oh, well, this is just an example. Okay, so this study gave parents information about sunburn risk when entering the zoo. So let's look at an idea of what kind of design this is. Here we have the average sales of hats. This is how many hats they're selling at the gift shop. And let's see. Then we have here the number of hats they're selling upon post-test, okay, and then we have in here we have post-test in the kind of light blue, and then in the darker blue we have the pre-test. So let's take a look at what was happening. So initially we had one group that was warned about sunburn risk, one group that was not warned about sunburn risk, and so we have an intervention group. These people got information about sunburn. These people got no information about sunburn. And then we did a pre-test. So the pre-test was prior to giving any information about sunburn. These guys were buying hats a little bit more than these guys, right? But once they give information about the sunburn risk, which is here, afterwards, these guys bought hats a lot more. And so these barely changed because they didn't get any information pre-test and post-test, but we can kind of see that the difference pre-test to post-test is much greater in the intervention group, suggesting that giving information about sunburn risk allows you to sell more hats and make some more money. Okay, moving on. Okay, the advantages of pre-testing. Well, what's nice about pre-testing is it allows you to see whether your groups are equivalent to begin with. So what we want to know is, okay, so we randomly assigned, especially if your groups are small. Let's say we have 20 people, we randomly assign them to take vitamin C versus not taking vitamin C. And our groups are fairly small now, they're only 10 people apiece. So we want to be extra careful that we didn't end up getting a bunch of sick people in one group. For example, in our control group, we don't want a whole bunch of sick people in there versus in our experimental group. So what we do in that case is we pretest, and just to make sure that those groups are equivalent. And so we want to make sure those groups are exactly the same to begin with. And now, if those groups are relatively equivalent to begin with on the pretest, now we do the intervention. Now we give vitamin C or no vitamin C. And now we look to make sure that those groups have changed afterwards. Now, the only thing that may be a problem with the pretest is it may give away the purpose of the experiment. So if we do a pretest on people's health and we ask them about their health status, then they kind of know what the experiment is about, and they might surmise that, oh, I see, after this pill I should be getting healthier. And in that case, even after taking the placebo, sometimes people will say, oh yeah, I'm healthier afterwards, even though they really didn't even get any vitamin C. So sometimes people act weird when they know the purpose of the experiment, and the point of that is the pretest kind of is a giveaway that way. Okay, well, we're going to start this one in the next video. So I'm going to go ahead and stop sharing and stop recording here. Watch the next video and you'll find out about objective 4 and 5.